Lesson 77 is going to deal with binomial expansion. It's going to talk about writing all 6 terms. The best way I know how to describe this is to start you off with, goodness, the term just left my head. Well, Pascal's triangle. So 0 terms equals 1, okay? Or 0 exponent, sorry. So our exponent number goes here. If I've got 1 as an exponent, then I'm going to get each of those individual things. Okay? Essentially what we're saying is in the event where I had, say, a plus b to the 0, that's going to be equal to 1. If I had a plus b to the first, I'm going to get both a and b. My coefficients are 1 and 1. Does that make sense? All right. If my exponent is 2, I have 1, 2, 1. All right, so coefficient is 1, then 2, then 1. Okay? My exponent is 3. It goes 1, 3, 3, 1. Okay? 4 as an exponent is 1, 4, 6, 4, 1. We'll go as far today as 5, but hopefully you see the pattern is 1, 5, 10, 10, 5, 1. Okay, so Pascal's triangle, if you know how it starts, at least to 2, from 0, 1, and 2, then the pattern's pretty easy to see. You're always going to get 1 as a first, 1 as a last. And if you're wondering, well, how do you get 2? 1 plus 1 is 2. So, okay, right? 1 plus 2 is 3. 2 plus 1 is 3. 1 is always going to be my last one. Okay, so I go from the top down. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Okay, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Last one's always going to be 1. It is. Yep. So do we understand the pattern of how to do Pascal's triangle? Okay. These numbers in here represent the coefficients to those values, okay? So if we go back and we look at question number 1, it says write all 6 terms of b plus c to the 5th, okay? So my coefficients to those 6 terms, let's change this around so that we're looking at b plus c to the 5th, all right? We have 1, 2, 3, 4, 5, 6. Those are going to be my coefficients. Now, the nice thing about this is that it's just b plus c. They didn't put anything else in front. We're not working with negatives. So as I drag this down, I'm going to show you a quicker way to do a simple question like this. All right. As we look at b, b is first, c is second. Okay, in terms of what we saw up there. So b is going to start off with 5 exponents, okay, or it's going to be b to the 5th, whereas c is going to be 0, okay, and this is going to go down through 4, 3, 2, 1, all the way to 0. This is going to go up 1, 2, 3, 4, 5. The second term will start at 0 and go up to the maximum. The first one will start at the maximum and go down to the minimum, okay? Whatever my exponent was that I started with is my maximum, okay? 0 is always the minimum, okay? So from here, I'll drag this down again, okay? And because there's nothing else in front, we're just going to use our coefficients. So my first coefficient was 1, which I don't have to necessarily write, but I'm going to get b to the 5th. Because what would go next to that would be c to the 0, but because it's c to the 0, I don't have to list it. Okay? And because it's plus, everything is going to be plus. So the next coefficient is 5, and I'm going to put b to the 4th, c to the 1st. Next coefficient is 10, b to the 3rd, c to the 2nd. Next coefficient is 10, b to the 2nd, c to the 3rd. Next coefficient is 5, b to the 1st, c to the fourth, and our last coefficient is going to be c to the fifth. Okay, any questions about this? We covered this in Algebra 2, so it should be more of a reminder than anything else. You can look at question number, if we look at question number 4, notice it says just write the fourth term, and you'll notice it's very similar. It's x plus 5 to the fifth. So if we were looking, let's say we used question number 1 to answer the same question, right? The fourth term in here would be 1, 2, 3, would be this one right here. That's all I would write is 10 b to the second, c to the third, but because they're using x and y, we would write that as 10 x squared y cubed would be my answer there. Now, the only thing that they do different on their answer for that, I don't know if this is, let's see if this is multiple, no, it's not a multiple choice, but they put it as 10 y cubed x squared because they want to put their variable with the highest exponent first. I would accept that as your answer, right? Because multiplication is commutative, I can move things around. Okay, it's not going to change the values. So do we feel like we got kind of a handle there on your binomial expansion? I think number 3 says expand c plus d to the fifth. Which of the following is a term in the answer? Well, because we're still working with the fifth, we know we're not going to get 20 as a coefficient, right? And we know we're not going to get 15 as a coefficient. So we're left with 10c squared d cubed or 5c squared d cubed. Okay. And our answer on that should be B. Okay, you're working with the same stuff, so if we come back over here, let's see, what did they have? I think basically it ends up coming out as similar to the fourth term. C squared d cubed. Yeah, it's the fourth term matching up. Okay, just different variables. All right, any questions about binomial expansion or Pascal's triangle? I don't know of another way to get these coefficient values to 5 to 10, or the 1, 5, 10, 10, 5, 1, other than to do the binomial, or other than to use Pascal's triangle. Okay? So past that, though, this actually works out pretty handily. All right, number 4 is going to move us over to lesson 78. And these are hyperboles. Okay? We've done some of this kind of work before. If you remember, where we just looked at the denominator, we got the plus and minus values of the square roots of the denominators. Okay, this is pretty similar to that. Okay, so number 4, given the hyperbole 25x squared minus 16y squared minus 400 equals 0, write the equation in standard form and find the coordinates of the vertices in the equations of the asymptotes. Graph the hyperbole. So there's a bit more here than what we had worked with. Okay, so they start you off with 25x squared minus 16y squared minus 400 equals 0. So going on what you already know, what would be your first step? We're not, this is not going to be the equation for a line. Okay, it's a hyperbole. Okay. Not yet. All right, so just as a refresher, because I feel like maybe we're, okay, this is our standard form of this, right? So if I'm trying to get my above equation into that format, right, Do you remember? I mean, we had this question. We had a question similar to this on our test.
It was the circle question.
You're thinking of, if this had nothing to do with shading. Okay, let me look, see if I can pull up the question from the test. It was close. It was number 9. Okay, this was the question. Okay, you had x squared over 9 plus y squared over 4 equals 1.
Yeah, it's a circle question.
Well, it's not a circle. It's an ellipse. So this is a lot like that. Your hyperbole ends up working out very similar to how your ellipse worked out, where we knew that we were going to get x equals plus or minus 3, y equals plus or minus 2, right? We have a similar situation here, but I've got to get it into this format, okay? So you're not trying to get y by itself on one side, are we? No. Okay, so let's take this and look at it again.
Add 400.
Good. Add 400.
Then you put 0 for x and divide by x.
You're kind of jumping the gun a little bit. 25x squared minus 16y squared equals 400. Divide by 400 on both sides. Why? Because this has to equal 1 over here.
Oh.
Right? You see what I'm saying? All right, so we need to reduce we know that this equals 1 now. We need to reduce the fraction of 25 over 400. 1/16. So that's going to be x squared over 16 minus what's 16 over 400? Probably something like 1/25. Y squared over 25. Okay? Now, the difference between a hyperbole and an ellipse is that this is not positive. Okay? All right. But we can still go at this similarly. Okay? For instance, we can plug in 0 for y. If we do that, we know that our x value is going to be plus or minus 4. Right? Can we see that? Because the x is positive. Right? But because the y is negative, the y is going to be the positive and negative, okay, square root, but not just that, but 5i, because keep in mind this is negative. Okay? And it's a negative square root. Right? So do we understand how we got positive and negative 5i out of it? Everybody. I want to make sure I got everybody on board first. Okay. All right, so let's kind of do some scrolling here. Let's see. So what we are going to use for the vertices of our ellipse are going to include, in this case, the x, well, let's see, right here. Because sometimes the y will be a standard number, like what we got with x here. Sometimes it might read off as something like 25y squared minus 16x squared. Okay, in which case the x value would be associated with the I. Okay? So our vertices here are going to be 4, 0, and we should get to negative 4, 0. Okay? Our asymptotes, and I'll explain what those are here in a second, are going to be attached to the I values. So 0, 5i, and 0, negative 5i. Oh, I'm sorry, I messed that up. Your asymptotes are a slope. So rise over run, so your y over your x. So y there is going to equal 5/4 x and negative 5/4 x. Rise over run. Did we get that part of it? Okay, we at least know where we got that from. Okay. The next part comes into actually graphing it. Okay?
The slope part of the second one, would it still be positive because you have a negative 4?
Okay, so it's a good question. He said, wouldn't it still be positive? All right, so there's actually 4 possibilities, right? Because I have 2 y's and 2 x's. All right, so stick with me here for a second. I'm going to verbally explain this. All right, negative 5 over negative 4 is 5/4, right? And 5 over 4 is 5/4, correct? 5 over negative 4 is negative 5/4, and negative 5 over positive 4 is negative 5/4. All right, so no matter what, I should get 1 positive and 1 negative, because 2 of those possibilities will be positive, 2 of those possibilities will result in a negative, but they're going to result in the same positive and the same negative. Okay? Okay. So the first thing I'm going to do is I'm going to go with my vertices, 4, 0. So let's 1, 2, 3, 4, 1, 2, 3, 4. Okay. The next part after that is the asymptotes. Okay. So starting at the origin, going up 5 over 4, up 5 over 4, those types of things. So okay. So if I'm going up 5, 1, 2, 3, 4, 5 over 4 gives me something like that. Okay. Down 5, back 4, 1, 2, 3, 4, 5. Okay. Something that looks like that. And this is that line. That didn't work. It should have gone through the origin. I must have messed something up. Let's try this again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's probably just a matter of I'm not working with graph paper than anything. All right, and then in the reverse, we'd go down 5 over 4. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Something looks like that. Okay, so those lines, those red lines there represent our asymptotes. But those are not my my hyperboles. My hyperboles are going to be from here out to there. Okay, so they're going to follow these asymptote lines. Does that make sense? Now, the reason I mention the positive and negative values in the i's is that if y had been, let's say, just positive and negative 5, and x had been positive and negative 4i, okay, the x had been negative, right? Then instead of having it open left and right, it would have opened up and down, okay? Does that make sense? All right, so let's look. You get, that was 4. Look at 5. Okay, we're going to go through the same processes here, but notice that y is positive. So which direction should it open? Up and down, right? Because I know that I'm going to get, well, actually, yeah, because my y up here in my equation is positive. My x is negative, so I know it's going to open up and down. So there's really only, unless they did their work wrong on A, there's really only one possibility, and that is that the answer is A for number 5. Okay? But the first thing that we would do is we would add 324 to the other side and then divide by 324. Right? What is 9 divided by 324 as a fraction? hopefully it's 1/36. Okay, did that come out correctly? Right, what's interesting to me is that in most of the questions that I see, that because the x is 36, that 9 divided by whatever number we're using is going to use the x value as the denominator, and the x is going to use the y value as the denominator, so I'm guessing that 36 over 324 is 1/9. Does it come out that way? All right, so the equation that you're working with is y squared over 36 minus x squared over 9 equals 1, which means that my vertices in this case are going to be the positive and negative square root of 36, right, which is 6. So I should be using 0, 6, and 0, negative 6 for my vertices. My asymptotes are going to be, well, if y is positive and negative 6, then x is positive and negative what? 3i, very good. Okay, don't forget the I. Which means if we're doing our asymptotes, and asymptotes are rise over run, then y equals two things.
0, 6, and then 0, negative 6.
No. Asymptotes are slope.
Oh, yeah, okay. 6 over 3.
Which is?
2x. 2x.
Okay. So our asymptotes are 2x and negative 2x. We understand our vertices. So at this point, what I'm going to do is I'm going to go up 6 and down 6. Right? I got those for that. I can make my asymptote lines, and that's going to tell me, it's going to show me how wide those hyperboles are going to open up. Okay? Those asymptotes are the constraints for the wideness or the narrowness of the hyperbole. So A is your answer there, and that's it.
It's actually a lot easier than our shows that
So does it make a little bit more sense? Did we go through asymptotes in Algebra 2?
maybe a little.
Must have.
No, Algebra 1.
In Algebra 1. Okay. All right. So hopefully this makes at least some sense to you guys.